Sorry about that. Cover in these first 3 weeks, and that's been able to transfer those. So we done a little bit last week, but we're going to cover in these skills through the course. If we look at formula for the volume of radius squared times the length of the cylinder. So the cylinder, and then you multiply that by length. Area. Formula says the volume expressed as in the length. So you need to know the volume. So variables multiplied by each other or constants could over the side. Happy with that? Yeah? So, slightly different type of equation now, one that's got an addition involved. So this little v equals u plus at. Alright, well, final velocity, u is the starting velocity, a is the acceleration, and t is time. You don't need to worry about too much about that at the moment, but that's what it is. What we're interested in is making u the subject of that equation. Yeah, so we want to get this at over to this side. How is it attached to the u? Yeah, what do we need to do? Yeah, subtract at from both sides. So writing that out in full, we have v minus at is equal to u plus at minus at. And like I say, eventually we won't bother to write out longhand. I would like to see you doing the separate steps to move things when we get to more complicated formulae. But here, at plus at minus at cancel out. And therefore we end up with u is equal to v minus at. And one of the common mistakes looking at that from the start is, well, I'm going to divide by t. You can't do that because u is not multiplied by t as well. It's almost a reverse BODMAS. You've got to get rid of the addition and the subtraction first, and then the multiply and divide. So you're going in a slightly like reverse situation. Okay, and you'll see that when we do some other examples. There's a common mistake to do things in the wrong order. Okay, so another common formula is the Pythagoras Theorem formula. Square on the hypotenuse is equal to the sum of the squares on the other two sides. So we've got z squared is equal to x squared plus y squared. And we want to make it rearrange for x. We want it to be x is equal to something. Well, we're going to start with that. Ideas. Y squared is a number on its own, so we don't have to worry about being squared. You can actually move it all in and deal with one entity. Please. Okay. Oh, okay, that's fine. Yeah. Were you here last year, Kirsty? Oh, okay. That's right. Don't worry. I'm Mike, by the way. You were here last week, yeah? Yeah. Oh, that's right. You went home ill, didn't you? Okay, so yeah, we're rearranging this for y squared. So the first thing we're going to do is subtract y from both sides. Yep. So we do z squared minus y squared equals x squared plus y squared minus y squared. At this stage I'm writing them all out. Yeah. And those two, plus y squared minus y squared, cancel out. So leave just that. X squared is equal to z squared minus y squared. What's the mathematical opposite of square? Square root. If we square root both sides, so we got, I'm going to write that x squared square rooted is equal to z squared minus y squared all square root. Remember, you must do it to all of it. Okay. By the way, that symbol, the square root symbol, all the way over that term, that expression, two terms, one subtracted from the other, means effectively, in terms of your calculator and everything, there are brackets around that term in there. It is that whole term evaluated first, and then the result square rooted. Yep. So that implies that there's brackets around that expression. Okay. And then, having done that, that and that cancel out. So we end up with the term, or with the formula, x is equal to the square root of z squared minus y squared. Okay. Because these two, remember, like I said, there's implied brackets around there. So it is that expression square rooted. So if you're doing that in your calculator, that will calculate z squared first, calculate y squared second, take the result of y squared away from the result of z squared, and then take the square root of that answer. That's that order of precedence, remember. Brackets first, indices. So these indices are inside the brackets, so they get done first. Then the subtraction that's inside the brackets, and then lastly, the square rooting. Whereas this is just one number squared with the square root applied, so they cancel. Okay? Yep. Any other questions so far? Okay, now I'm going to get you to, I'll put them up on the board for those that haven't. Some of you might have printed them off, some of you might have them on your phones or whatever. I'm going to put the two questions I want you to try now up on the board. Right, so the first one, just remind me what it is. TQ1. X plus 3y equals t. Yep. So, where do we start with that, do you think? Yeah, we have to do the addition first. So we have to get rid of this added term. So therefore, we're going to subtract x on both sides. That's the operation we're going to do. So doing that would mean we had x plus 3y minus x on one, and on the other side t minus x, because what we do to one side we must do with the other to keep that balance. And that means these two x's cancel out, because plus x minus x means nothing. Yep. So we now left with, having cancelled on the left hand side, 3y is equal to t minus x. So we can get rid of this pesky 3 now. We'll have y on its own. That's the only thing we're aiming for. So how is the 3 and the y attached to each other? What mathematical operation? Multiply. So the mathematical opposite of multiply is divide. So we divide both sides by 3. That's what we're going to do. So here we go 3y divided by 3 is equal to t minus x, and we must divide the whole thing by 3. Yeah, so that again, that line being all the way, we don't put them on normally, but that implies brackets around that term. Yeah, if you're not using the fraction term like that, you need to put brackets around that top term and then divide it by 3. Because you must take x away from t first and then divide the result by 3. Okay, but I would recommend using the fraction button on your calculator for that. Alright, and then we have here 3 divided by 3 is 1, so they cancel. Bottom, leaving us with our formula we're looking for, which is y is equal to t minus x divided by 3. And I think that's the answer that was on the sheet. Yep. So it's this, remembering what these mathematical factors are, is one thing that you need to do. The other thing you need to do is the order to do things in. Okay, looking at that and saying, it's not always obvious straight away what you need to do. And that'll only come with practice. Hang on, let's just, so just one over here, x plus 3y equals t. Yeah. I mean, eventually you'll end up with the same thing, because you'll move that over there to have 3y, minus 3y on that side. One bad thing about that already is you've made it negative. Yeah. And 2, you haven't gained anything, because we're trying to get y on its own, and you're taking it away from one term. You're taking it away from this term and adding it to that one, or subtracting it from that one. So what you've got is x is equal to t minus 3y, yeah, but you're then going to still have to take away t from, so you're going to end up with x minus t is equal to minus 3y, yeah, and then you're going to divide by 3y, so you're going to end up with x minus t, over minus 3, yeah, is equal to y. And that still mean the same thing, But you've got a strange term, and that's a much longer way to go around about doing it. So everything is led. There are cases when I would recommend you move the term that you're trying to get on its own. And that would sometimes be when that's either on the bottom of the fraction, get it up the top, or if that's negative, adding it to the other side will make it positive. So there are times when moving the term you're looking to get on its own from one side to the other is helpful. All right, we might see an example like that in a minute. And it is practice. That's the only thing that will help you to get to know what you need to do. And the second question was, new page. TQ2, just remind me what it was, please. V squared over R, one of the three formulas for power that we looked at in science last week. And we want to rearrange for what? V? Make V the subject. So this time we want that term V on its own. So what are we going to do first? Yeah, multiply by R. Attach to V squared by division. Yeah. So we multiply, we'll cancel out. So we put an R up here. So we're going to say P times R is equal to V squared R divided by R. And the two R's cancel out to leave. And I'm going to just write it the other way round, because I want it on that side anyway. P times R. And how do we finish it off? Square root both sides. So we go square root, that and that cancel to leave us with V is equal to the square root of P times R. Yep. So that's what's it about. How are the two terms that you want, or items that you want to separate, how are they attached to each other? What's the mathematical opposite? And care about what order you do things in is the key to being able to do this. All right? So, what we're going to do now is have a look at one that's a little bit more tricky altogether. Transpose that formula, and I have to say I have no idea what it's for calculating. It's not one I recognise. P is equal to a squared x plus a squared y over R. We want to make A the subject. What we've got now is a formula where A, the item we want on its own doesn't appear only once, we've got it twice. So here, as well as getting it on its own, we need to get the two A squareds together. Alright? So, a bit more tricky. But where would we start with this formula, do you think? What item can we move straight away to start with? Yeah, multiply by R. So take that formula and we multiply by R. So we've got PR is equal to A squared x plus a squared y, all multiplied by r, divided by r. And that's important, that you're multiplying the whole thing by r. Yeah? Because that way, cancel that, cancel that. Yeah? But we've still got these a squared in here twice. We need it on its own. So what do you think we can do? No, because if you square root, you'll be square rooting all of it, and you'll be, so therefore you'll be square rooting the x and the y as well. Think back to the first week, the skill we learned that we can do with brackets. You would if you could do if there was something outside the brackets, but there isn't. What's the opposite of multiplying out of the brackets? Factorising. Yeah. So we got two terms in here: a squared x and a squared y. They have a common factor, a squared. So what we can do is factorise for a squared. So what we do here is we keep our PR like that, not changing that side at all. All we're doing over here is taking a squared outside the brackets because that's a common term, and leaving x plus a inside the brackets. Y, sorry. Yeah. And you all agree that if we multiply out these brackets, we end up back with that top line. Yeah? So instead of multiplying out brackets, we've actually done the opposite of that, which is to factorise. So that's handy. We've only got one a squared now. And how is that a squared attached to that bracketed term? Multiply. So if we divide by, and because that's in brackets, we can do it all in one go. Divide by x plus y. So over here, we have PR over x plus y equals a squared x plus y over x plus y. And those two terms cancel to leave CR is equal to over x plus y is equal to a squared. One final thing we need to do to get a on its own, that's square root. So we go a squared, square rooted, is equal to PR over x plus y, square rooted. And that cancels. To leave I is equal to the square root of PR over X plus Y. Yeah. So where you've got two versions of a term, two a squareds or two a's on their own, you're looking to get that in a position where you can factorise that out as a common term. So everything you do prior to that factorisation is trying to achieve the ability to be able to do the factorisation. Yeah. Okay, everybody got down what they want from that? As you've seen, there's an example for you to have a go at shortly. What about this one? Make f the subject of, and that's the little f. So here we have to be careful that they've got a capital F and a lowercase f, and they are different. Okay, case matters in mathematics. So where do you think we'll start with rearranging or making f the subject of? I'll write this out because not y is equal to 3 brackets capital F minus lowercase f over L. Where are we going to start? Yep. How's Lewis? Yeah. Multiply out the brackets, yeah? We've got, the issue here is, well, you could do something else first. The issue here is we've got to separate this capital F and this little f in here. So if we multiply out the brackets, we end up with y is 3f, capital F, minus 3, little f, all over L. I'm trying to make this f here, but the lowercase f the subject. What are we going to do next? What do you think, Christian? Yeah, okay, I'm just seeing if you've got an idea, and then think about broad mass in reverse. Normal way round, we have to do multiplication and division first. But when we're rearranging, how is this? Because it's all of that divided by that. It implies that top bit's in brackets. We need to shift this L first before we can do anything with the numerator. So how can we get the L over the other side? Yeah. And bear in mind, we could have done that first. We could have done that up there and then multiplied out the brackets. Wouldn't make any difference. Okay? So if we multiply by L, are we okay if I stop doing this, write the whole thing out and cancel now? Are you happy if I don't do that anymore? Have I done enough of that to show you how it works? Or do you want me to carry on? Y over L, this side, yeah, leaves 3f minus 3 little f on that side. Y times L. Spotted my deliberate mistake. Y L, yeah. So multiply by L. Multiplying by L on this side means the L on the bottom cancels. Okay, I'll do that, yeah. So we're divided by L, and that whole thing multiplied by L. And then those two cancel out. Yeah. Alright? So what we have now is YL is equal to 3F minus 3 little f. Next. You could divide by 3, but that's maybe not. Hang on. Just there's in that term, sin divide by 3. That's an argument not to multiply out the brackets first. Yeah. Because if you do. I'm going to leave that on there, and I'm going to do a new slide, and I'm going to not multiply the brackets first, and just that'll show you what I mean. I'll finish that off if necessary, but we got make f the subject of and just read it out for me, please. These can frustrate at times. Yep. Now, if we start off, there was nothing wrong. You'd end up in the right place. But I'll show you what more you've got to do to get it all right. And this is the easier way. Yep. Multiply by L. So we end up with YL is equal to 3 brackets f minus little f times L over L, and those two cancel. Yeah. So we now have this as our formula. Now what can we do? What someone wanted to do with the other one, what's the separate term? Divide by yeah. So we got YL over 3 equals 3 f minus f over 3. Now the 3's cancel out. So we have currently YL over 3 is equal to f minus f. Next. Sorry? Take the, yeah, there's, if you take away f, you end up with this. YL minus 3 take away capital F is equal to what? Minus F. But we don't want minus F, we want plus F. times by minus f. Which little dots? Divide by f, that is. That's what we... Yes, if instead of doing that, you do plus little f to both sides, right? Because what that happens then is you end up with, yeah, you have YL over 3 plus little f on that side, yeah, is equal to f minus little f plus little f, and those two cancel. Yeah, and that's, now we've got f positive. What can we do to this? What can we do to here? Remembering that that is a term. How is it attached to f? So take it away. And we can do that whole term in one go, because remember, y and l are numbers. That's just a number. So we can go subtract y l over 3 from both sides. So we end up with, I'll write it out in full, YL over 3 plus F minus YL over 3 is equal to F minus YL over 3. And that cancel. All see that? And if it looks like you're going to end up with a result that's negative, just add it to the other side and subtract the bit that was that's on that side to get it positive. And that's the easiest way to do it. Alright, so our final answer is that F is equal to F minus YL all over 3. That's all there is to it. Okay. Oh, okay, yeah. Going back where we were with this. Yeah. What we could do is we want 3f on its own. So using what we did with the other one, if we add 3f what happens then? We get YL yeah, you're going to end up in a muddle here because multiplying brackets out too soon has caused an issue of terms. I mean, what you're saying, if you want to divide 3 by 3 first, what you're effectively doing is saying I'm going to put the brackets back on the original term, because what you're doing is this, divide by 3, and effectively they can be separated. So when you cancel, So that's divided by 3, and you cancel both of those go. Yep, so you're right, you could do that. And then you're back where you were with the one on the next page, because you're left with YL over 3 is equal to F minus F. You're back where you were with the other problem. What you've done effectively, really, is put those brackets on that Lewis had me take off in the first place. And I'm not knocking you, because these are things that you got to try and eventually understand what you need to do at the right time. Yeah, but not necessarily in here, because remember there's that thing of you've got to do some things in reverse. So you've got to do what's outside the brackets first, then multiply the brackets out, because you're doing it in reverse. Yep. I understand this isn't easy, I do. That's why we're kind of spending 2 or 3 weeks on it up front with a bit of algebra just to get things moving. Oh yeah, then. Oh, what, plus 3? Yeah. So not dividing through by. Let's have a look. So not dividing through by 3f there. Doing. Oh, I get rid of all that. So we got YL is equal to 3f minus 3 left. And is it possible to complete by going plus 3f? So we got YL plus 3f is equal to 3f. Yep. And then you're going to have to subtract YL from both sides, so you end up with 3f there is equal to 3f minus YL, and then we've got to divide by 3. So you end up with f is equal to f minus YL over 3. Is that what we ended up with last time? So you do end up in the right place. Yeah. Yeah, well, back on this one. Negative. That's right. Yeah. Yeah. That's a bit of a less understandable way, because you've got this flat as a more awkward way to end up with the right answer, but the right answer nevertheless. So if that was a problem you were doing in your assignment and you'd done it round that way, you ended up with the right answer. There's no worries. Okay. If you write that out in full, Lewis, we've got 3f, yeah, that's equal to, so we're dividing that by 3, yeah, and we're doing, if you start, what you're saying is it 3f minus YL all divided by 3? Yeah. Yes, it is. Okay, but with that part of it, what that can be written as 3f over 3 minus YL over 3, and then that side cancels. Yep. So that's the right answer as well. If you give these variables some numbers in either that or the final answer we got, you'll get the same result. Alright? Yeah? Right. We'll have a look at one now. Bit tricky. D over D is equal to the root S plus P over F minus P. What do you think you might do with that? Cry. Cry. Any ideas? Trying to make P is two lots of it and trying to make it the subject. No idea? We could start there, couldn't we? So we end up with D over D all squared is equal to F plus P over F minus. Anyone know, using the laws of indices, how that can be written differently? Remember in here, this is D to the 1, because any number to the power 1 is itself, and this is little d to the 1. And if we've got indices in brackets, with number indices on the outside of the brackets, what does the laws of indices say? They multiply. So we can take these brackets away and write that as d squared over little d squared is equal to F plus P divided by F minus P. What we want is to be able to get, we've got to get these two lowercase p's together. How can we do that, do you think? Well, that won't make it positive, but we can multiply by F minus P in one go. So what we end up with is d squared F minus P over little d squared is equal to F plus P. Next. We're trying to get P. Yeah, because that's handy because we get rid of the fractions then. Got no fractions anymore if we do that. Yeah. So if we multiply by little d squared, yeah. So this is attached to that by division. So if we multiply, we end up with d squared f minus p is equal to little d squared f. There's brackets there as well. Multiply the brackets, you think? Right. D squared f minus d squared p equals little d squared f plus little d squared little p. If you divide both sides by big D squared, you're moving that D squared back that you had up there in the first place. You've got no fractions now. All you've got is two terms, one subtracted from the other, related to big D. We've got two terms related to little d squared, multiplied together and added together on this side. What we want is to get this and this, the two terms with little p in it, together. Yeah, that's negative this side. So let's not make it. So if we add big D p squared both sides, we end up with big D squared little f is equal to little d squared little f plus little d squared p plus big D squared p. So we've got our two p terms together now, which is going to come in handy in a minute. What we want to do is get rid of this one. Separate this one from them two. Yep. So we're going to subtract little d squared f. So we got big D squared f minus little d squared f is equal to little d squared p plus big D squared p. Now what can we do? We've got our two terms involving p together. Factorise. Factorise for p. So I'm just gonna switch those two round, so it's gonna end up with p is equal to on the left hand side. So we're pulling p outside a set of brackets, and inside going to have little d squared plus big D squared is equal to this term, big D squared F minus little d squared F. Divide by that bracketed term all in one go. It's in brackets. You could factorise the other side if you wanted to. Yep. Or you can leave that. What we're trying to do is get the P and the yeah. So we're going to divide by D squared plus big D squared. So you end up with little p on this side. D squared F minus little d squared F over D squared plus big D squared. And as you rightly say, F is a common term on the top there, so you could, if you wanted to, F big D squared over D squared plus capital D squared. And they don't cancel, by the way, because that's plus and that's minus. Right? But happy with that, that would be fine. Okay, it's got P on its own, and if we had figures for these letters, we'd be able to do a calculation to find P. Right? So last up, let's have a look at the question 5. Okay, if you can write it down, because I just want to add some admin in the register. And save this